Welcome back. I am your expert technical instructor. In this session, we tackle a critical security aspect of configuring and managing repositories: how to permanently remove specific data, such as exposed secrets, from source control. Within enterprise DevOps environments, configuring and managing repositories requires an uncompromising approach to security. One of the most severe operational incidents an engineering team can face is the accidental commitment of sensitive data, such as API keys, database connection strings, or cloud provider credentials, directly into the source control repository. Because Git is mathematically designed as an append-only, immutable cryptographic ledger, simply deleting the file in a subsequent commit and pushing it to the remote repository does absolutely nothing to solve the security breach. The sensitive data remains fully accessible in the repository's deep historical timeline. Anyone who clones the repository, or any automated tool scanning the Git history, can easily extract the leaked credential using standard checkout or log commands. When specific data like this is exposed, it constitutes a critical security vulnerability that can lead to catastrophic data breaches, unauthorized infrastructure access, and severe regulatory compliance violations. Therefore, standard file deletion is entirely insufficient. Organizations must deploy advanced, aggressive repository manipulation techniques to systematically rewrite the entire cryptographic history of the project, mathematically erasing every trace of the compromised data as if the commit had never occurred in the first place. This represents the incorrect approach. While it removes the file from the current working directory, the secret remains permanently embedded and fully readable in the historical Git commits. This flow demonstrates the danger of naive deletion. A secret is committed, a standard removal is executed, but the secret remains permanently in history, creating a major vulnerability. Before we dive into the complex mechanics of rewriting Git history to purge specific data, we must clearly define the absolute first step in any credential leakage incident response. Do not immediately begin rewriting your repository history. The instant a secret is pushed to a remote repository, such as Azure Repos or GitHub, you must operate under the strict assumption that the secret has already been compromised by malicious actors or automated web scrapers. Therefore, the immediate mitigation strategy is to instantly invalidate, revoke, and rotate the exposed credential at its source. If an Azure Key Vault token was committed, immediately delete that token within the Azure portal. If an AWS access key was exposed, deactivate it instantly. Rewriting Git history is a highly disruptive and time-consuming administrative process. Attempting to clean the repository while alive, active credential sits in an exposed state leaves your infrastructure completely unprotected. Only after you have unequivocally halted the blast radius by neutralizing the credentials should you proceed with the surgical process of purging the specific data from your source control systems to satisfy compliance and security audit requirements. This Azure CLI command illustrates the immediate mitigation step, rapidly rotating a compromised secret within Azure Key Vault to ensure the leaked credential is rendered useless. The incident response timeline. Upon detecting a leak, immediately assume compromise, revoke the credential at the source, verify stability, and only then begin the Git history purge. To successfully remove specific data from source control, you must understand the profound mechanical implications of rewriting Git history. Git commits are fundamentally linked together in a cryptographic chain. Each commit object contains the SHA-1 hash of its parent commit. When you utilize advanced tools to purge a file from a historical commit made 6 months ago, you are mathematically changing the content of that specific commit. This alteration changes its cryptographic hash. Consequently, because the parent hash has changed, the hash of the subsequent commit must also be recalculated, initiating a cascading chain reaction that mathematically alters every single subsequent commit leading up to the present day. This completely rewrites the timeline of the repository. While this successfully obliterates the sensitive data, it also creates a massive synchronization conflict for your entire development team. Any engineer who currently possesses a local clone of the repository will find that their local history no longer matches the newly purged, rewritten remote history. Attempting a standard Git pull will result in catastrophic merge conflicts. Therefore, removing specific data is not merely a technical execution. It is a highly coordinated administrative event that requires explicit team-wide communication and synchronized repository resets. Running this command before and after a history purge will explicitly demonstrate how the cryptographic commit hashes have been entirely recalculated across the affected timeline. This visual shows the cascading effect of rewriting history. Altering commit B to remove the secret generates a brand new commit B star, which forces the recalculation of commit C star. Historically, developers relied on the native Git filter branch command to scrub specific data from repositories. However, this command is notoriously slow, highly error-prone, and has been officially deprecated by the Git community for extensive history rewrites. Today, enterprise transformation teams must leverage modern, specialized utilities. The BFG Repo Cleaner is a remarkably fast, Java-based alternative, specifically designed for removing large files or replacing hard-coded passwords with placeholder text across an entire repository's history. BFG is incredibly efficient, often running hundreds of times faster than Filter Branch. Alternatively, the official modern standard recommended by the Git project is the Python-based Git filter repo utility. This tool provides unparalleled precision, allowing administrators to surgically extract subdirectories, strip massive binary blobs, or obliterate sensitive configuration files from every branch and tag simultaneously. By executing Git filter repo, the tool rapidly parses the internal fast export stream, recalculates the cryptographic hashes, and generates a pristine, cleansed repository devoid of the compromised data, ready to be forcefully pushed back to the centralized Azure DevOps server. This powerful Git filter repo command systematically traverses the entire repository history, forcefully inverting the path to mathematically obliterate every trace of sensitive-config.json. The purging workflow using modern tools. A dirty local clone is processed by Git filter repo, which parses the internal stream, obliterates the path, and yields a pristine clone. Once you have successfully utilized Git filter repo to cleanse the repository on your local machine, the next critical phase is synchronizing this new, pristine history with your central Azure repos or GitHub server. Because the commit hashes have been fundamentally recalculated, a standard push operation will be violently rejected by the server as a non-fast-forward update. You must execute a highly privileged git push force command. In tightly governed enterprise environments, the main branch is heavily protected by branch policies that explicitly prohibit force pushes. Therefore, a repository administrator must temporarily suspend these branch protection rules to allow the rewritten history to overwrite the remote server. After the force push is complete, it is imperative to immediately re-enable the branch policies. Additionally, administrators must be aware that simply force pushing does not automatically delete cached data associated with historical pull requests or cached CI/CD pipeline artifacts that may still contain the exposed secret. You must thoroughly audit Azure DevOps or GitHub to manually scrub any lingering cached references to ensure absolute compliance. These aggressive commands forcefully overwrite the remote server's branches and tags with your locally rewritten history, obliterating the old, compromised cryptographic timeline. The force push execution plan. Start with the clean local repo, temporarily disable policies, force push the changes, immediately re-enable policies, and manually clear remote caches. The immediate aftermath of forcefully pushing a rewritten history is chaos for the development team, if not properly managed. Every single developer's local clone is now fundamentally incompatible with the remote server. If a developer unknowingly executes a git pull or attempts to push their local branch, they risk accidentally reintroducing the compromised history back into the centralized repository, completely undoing the entire purging effort. To configure and manage repositories post-purge, explicit team coordination is mandatory. Every engineer must halt development and synchronize their local environments with the new reality. The safest approach is often for developers to completely delete their local clones and perform a fresh git clone from the server. Alternatively, they must execute a git fetch followed by a destructive git reset. Hard to forcefully align their local branch pointers with the newly cleansed remote tracking branches. Project managers must account for this operational downtime, ensuring that all unpushed local work is safely backed up, patched onto the new history, and that no traces of the purged-specific data remain on any local development workstations. This sequence instructs a developer's local machine to download the newly rewritten remote history and aggressively force the local main branch to match it exactly, discarding the old timeline. The team synchronization protocol. Once the force push completes, notify the team immediately so they can fetch and reset their local environments before resuming normal operations. To conclude this critical module, it is important to recognize that removing specific data from source control is a painful reactive process. World-class DevOps organizations prioritize proactive prevention. By implementing client-side pre-commit Git hooks and integrating robust server-side secret scanning tools like GitHub Advanced Security directly into your continuous integration pipelines, you automatically block sensitive data from ever entering the repository in the first place. This proactive governance drastically reduces risk and eliminates the need for historical rewrites. Please remember to like this video, subscribe to our channel, and visit quicktechie.com for premium certification preparation. At quicktechie.com, you will find extensive Q&A banks, high-quality ebooks, insightful audiobooks, hands-on training modules, and expert interview guides meticulously designed to accelerate your Azure DevOps career. Implementing secure repository practices is the hallmark of an elite engineering team. Thank you for joining me, and I look forward to exploring package management strategies with you in the next session. This basic shell script snippet represents a local pre-commit hook that automatically scans files for the word password, halting the commit process to prevent accidental leaks. The layered defense mechanism. Local pre-commit hooks scan for secrets first, blocking if found. Clean commits are pushed to the pipeline for secondary advanced security scanning.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.